Today we're going to present our green chemistry lab on biosurfactants. The purpose of this lab was to compare the power of two different types of surfactants, a chemical surfactant and a biological surfactant. Also, we wanted to demonstrate the emulsion reaction. The biosurfactant was rhamnolipids at 80% purity, and the chemical one was Triton X100 at 100% purity.
For the safety of this lab, one should wear protective gloves, a lab coat, and eye protection, because Triton X100 causes skin irritation and serious eye irritation, so wash away exposed skin thoroughly after handling. The materials of this lab consist of 9 test tubes with rubber stoppers, 1 test tube rack, 1 100 milliliter beaker, 1 glass rod, 1 analytical balance, 1 25 milliliter graduated cylinder, a 30 centimeter ruler.
And for the reagents, we use 22.5 milligrams of rhamnolipids in powder, 18 milligrams of Triton X100, 100 milliliters of canola oil, and distilled water.
Before explaining the procedure, here's a brief summary of what we intended to do. So we prepared solutions of diluted biosurfactant and diluted chemical surfactant. Then we mixed them with oil. After the mixture, we let them sit for 1 day and compared their height of emulsification zone. Finally, our hypothesis was that the emulsification zone of the biosurfactant would be greater than the surfactants.
When I went to meet Mr. Eric Desiel, he gave me rhamnolipids at 80% purity, and he told me that the best concentration for this type of rhamnolipid was 500 milligrams per liter. So we did the calculations respecting this data. At the second step on the sheet, we had to find the mass of rhamnolipids to put in the biosurfactant solution. So we used 500 milligrams per liter and found out that for a 15 milliliter solution, we had to use 7.5 milligrams. The third step, we had to find the mass for the chemical surfactant solution, and since it is at 100% purity and the rhamnolipid is at 80%, we had to decrease the mass we put in the test tube so it becomes at equal concentration. The fourth calculation was the easiest because it was only for the test tube of water, so we only have to put 15 milliliters of distilled water in the test tube.
And now that our calculations are done, we can start the procedure.
We use these calculations to prepare 3 solutions of each for more conclusive results. So we started off by labeling all test tube. For the rhamnolipid solution, Bio 1, Bio 2, Bio 3. For the chemical surfactant solution, try 1, try 2, try 3. And for the water solution, O1, O2, O3. Then you have to set up the analytical balance. You weight the nacelle, then you press 0, and you have to weigh 7.5 milligrams of rhamnolipids. Then we repeat this step 2 more times for the second and third solution of rhamnolipids. After weighing these really small masses, we're gonna have to measure 15 milliliters of distilled water and put it in the first test tube and repeat it for test tube 2 and test tube 3. The measurements have to be really precise because we're comparing two types of surfactants and we need the same conditions for both.
After pouring 15 milliliters of distillated water and incorporating the 7.5 milligrams of biosurfactants, we can mix the solution together.
Now part 2. It's basically the same thing for the Triton test tubes. So we wait with the analytical balance 6 milligrams of Triton 3 times. After that, we will measure 15 milliliters of distilled water and pour it in a test tube and incorporate the 6 milligrams of Triton previously weighted and just mix. For part 4, you just have to measure 15 milliliters of distilled water and pour it in the test tube that we identified: water 1, water 2, water 3.
And there are all the solutions we made. Measure 5 milliliters of canola oil, pour them into each test tube, and close them with the rubber stoppers.
Now we have to mix the 3 solutions labeled Bio 1, Tri 1, and O1 for the exact same time and exact same force. So since we didn't have a vortex in the lab, I decided to take the 3 test tubes in my hand and shake them at the same time 30 times from waist to shoulder. We had to repeat these steps for the test tubes too. So Bio 2, Tri 1, and O2. And when it came to the third step, we made some little experimental errors that changed our results. So enjoy.
Hope you laughed at our blooper. Now back to the lab. After removing all the rubber stoppers, you let the substances sit for 24 hours and come back for results.
So after 24 hours, we came back to measure the height of the emulsification zone. Contrary to our expectations, we found out that the height of the emulsification zone of the Triton solution, so the chemical surfactant, was indeed higher than the biosurfactants emulsification zone.
As seen in this picture, what we hoped to obtain for the test tubes O1, O2, O3 was the first test tube in the image in which the water and oil are clearly separated with almost or no emulsification zone. Because due to their density, the oil having a lower density would go on top, and the water having a higher density would go down. That happens due to the fact that no surfactant or biosurfactant removes the surface tension between the two substances. For the substances Tri 1, Tri 2, Tri 3, and Bio 1, Bio 2, Bio 3, we hoped to have something that resembles to the test tubes 5, 6, and 7 from the picture, in which almost all the oil or some of the oil is mixed thanks to the surfactant or the biosurfactant, which relieves the surface tension, creating a mix between hydrophobic and hydrophilic substances. The amount of oil that is non-emulsified depends on the precision of the manipulations during the lab and the power of the biosurfactant or the surfactant that is used.
Now the results. So first we see the three solutions, the three test tubes containing water and oil. There's a micro emulsion, but except that it's separate phases. Then there is the biosurfactants test tubes, and we can see in the third test tubes we lost all the oil, and there's no emulsion due to the fact that we dropped it on the ground. And in this third picture, it's the Triton test tubes. So we can see that it worked very well, and almost all the oil is emulsified except a thin layer on the test tube Tri-1. So this is our table of results. I will go over these results and focus on the results that contain little stars, as you can see with the Bio 3 and the Tri-1. So I will explain these later. So for the test tube Bio 1, it worked like as we expected. We measured 25 millimeters for the emulsified area and 5 milliliters for the oil on top. For the second test tube, so Bio 2, we can see that our procedure was well respected. We had the same values, so 25 millimeters for the height of the emulsified area and 5 millimeters of oil on top because it's less dense. However, for the third test tube, so Bio 3, we see we only measured 1 milliliter of emulsified area and 0 milliliter of oil. This was the test tube that we dropped on the ground when we were shaking the test tubes at the same time. So we lost all the oil, and there's only a small amount that left in the test tube. So this explains our value. Now for the Triton test tubes. So we can see that once again we were partially precise with our manipulations, because test tube Tri-2 and test tube Tri-3 have exactly the same values. However, as we can see in these pictures, it was very difficult to measure the height of the emulsified area because I don't know how to explain it, because the emulsification complex was formed in a different way. So if you measured on one side, you had a large height of oil layer, and on the other side you had a small one, and the same thing with the height of the emulsification zone. So this result differs from the others.
For the three water test tubes O1, O2, and O3, the height of the oil layer is greater than the height of the emulsified area, and that is due to the fact that it contains no biosurfactant or surfactant. However, we only used the water test tubes to help us see better the results between the surfactants and the biosurfactants.
In conclusion, we can see that our hypothesis was wrong. We thought that the test tubes with the rhamnolipids will present a bigger zone of emulsion than the Triton test tubes, because the rhamnolipids were supposed to be more powerful surfactants than the Triton. If we look at our conclusive results, so we exclude the test tube Bio 3 that we dropped on the ground and the Tri-1 that wasn't really conclusive, we can see that it is not the case. The conclusive Triton test tubes, so Tri 2 and Tri 3, both have a 32 millimeters emulsification zone and no oil on top. Contrary to the conclusive bio test tubes, Bio 1 and Bio 2, which have only a 25 millimeters emulsification zone and a 5 millimeters oil layer on top. I will finally go over our sources of errors. So first of all, I think when we build the protocol that we could have chose bigger masses, like to do bigger solutions, because to measure 7.5 milligrams of rhamnolipids and 6 milligrams of triton using an analytical balance was very difficult. We could have possibly made some errors when we were weighting these masses. Also, one big source of errors was when Maria dropped the test tube labeled Bio 3, so we lost an entire test tube due to an error. And finally, we could have made some errors when measuring the volume of distilled water or the volume of oil that we put in the solution, and this could have changed a lot of our results if we made this error. I hope that we were able to explain well our lab, even with our lack of English skills, and we hope that you understood why our hypothesis was wrong. Finally, this is an image of our lab protocol to conclude. Thanks for watching!